Welcome back to the hyperbolic suffering chamber. Me brain fried, but no feel like doing LeetCode. Must do LeetCode anyway. Why use more word when fewer do trick? So we are back once again, unfortunately, on this godforsaken website to do more problems. It remains unclear why we show up to do these problems, but if we spend too much time thinking about why we must do it, we will likely stop. So, in the essence of that, we are going to jump straight into the comments. Actually, there was something else I was going to say. My brain is tired. My brain is very much tired. This is why the after work sessions are not flames, because my brain is tense. I need to be loose like water, like Bruce Lee said. But instead, I am very tense. I'm not actually tense physically, but there's something about, I can tell when I used to meditate back in the day, there was a state you would end up in afterwards or there was a state that I would meditate to or get out of, and this is the state that I'm currently in. But it's kind of convoluted because this can also, it's kind of convoluted, but it's all to say, I think I'm having so much PFC activation that things are slowing down a bit. So I think I basically just need a break. It's just very interesting because too much focusing in one direction, I guess in specifically, I guess for me, for some reason, even if I had like a really, really long social media binge session, or I'm focusing on something difficult, I wouldn't say the social media binge session counts actually. Basically what I'm saying is my anxiety is a little bit higher, I think, because of finishing work. And I think not because work creates anxiety, but more so because the level of focus that I was in, I think, increases the activation. And too much activation leads me feeling a little antsy. Kind of like if you drank too much coffee. So it's like I feel like sometimes overstimulation can be like, oh, you're tired. But I think other times, other overstimulation can just be kind of like that, where the sensitivity is just a little higher. So I think that's kind of where I am. I think to fix that, I've been working on something at work that just has, we're doing a hackathon, which is pretty cool. But I was trying to get it to work, and I finally made some good progress. And I was pretty much in a programming daze for like 8 hours. So I'm out of that now, but yeah. You can tell, my speech is like all over the place. I'm like fumbling over my words. That is to say, we're going to do a recovery session today. So things are going to be a little bit slower paced. And the problem we're stuck on is actually going to require a lot of activation. So we might have to activate Goss himself. Maybe he'll tap us on the shoulder and guide us into the light so that we may I don't know what I'm saying, but we'll be reborn in his image, in Goss's image. But that being the case, we have some YouTube comments as per usual. We have from Tilo. Oh no! I saw this comment earlier today from Usama Denson. This is why you look like you're gonna cry, bro. I am. Oh my god, this comment is so funny, man. True, aren't you, bro? This website hurts me. The devs at LeetCode are hurting us. We have a comment from Tilo Clarenbeek. Maybe you should switch to x86 assembly to spice it up a bit. True. I wonder if they actually have that as a potential choice here. There's no way. That would be cool though. That would be really cool. I wonder. They do have C versions. Maybe C versions is hard. Maybe C is just hard. Maybe C versions are the hardcore versions. But that would be pretty dope. But yeah, they should add it though. That would be pretty dope. And then we have from Monka S with a legendary profile picture. Maybe you should switch to binary code to spice it up. Wait, these comments are relatively similar. Oh wait, okay. I think this. Okay, we're memeing. Yeah, true. C first, then WASM, then x86, then binary. Bro, we need binary. Someone has to say it. So we need to get in contact with the LeetCode devs to make that happen. But we do have many LeetCode employees in the Discord, though, so it should just be as simple as requesting it in the Discord. So, yes. That being the case, if you haven't yet, you should join the Hyperbolic Coding Chamber. This Discord is rapidly growing. We have hundreds of thousands of members that are joining as we speak. Actually, as we speak, I just got a notification. We reached Discord's server limit. So we're going to have to borrow some more actual physical servers from the United Nations. And hopefully you might be able to join if you click the link in the description of this video right now. So it's going to be close, but you're going to want to click it before it's too late. But that being said, what it's never too late to do is LeetCode. So we're going to have to return to suffering. We must return to suffering. We're going to do still a shorter session today. I'm going to try and wake up earlier tomorrow morning and do the session then. And I think that should be ideal. Also, I think I'm wearing the same fit from yesterday, so you already know what type time it is. So I'm just gonna jump into it. You can tell that I am stalling. We're gonna jump into the LeetCode. We have 25 minutes on the clock, and yeah, we're just gonna jump into it for the find content children problem. Assume you are an awesome parent, want to give your child some cookies, but assume you are an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Each child I has a greed factor. G represents children. I need to remember that, which is the minimum size of a cookie that the child will be content with. The minimum size of the cookie. Each cookie J has a size S sub J. So S is our cookies, basically. We can assign the cookie J to the child I if the cookie size is greater than or equal to the child's greed factor. Your goal is to maximize the number of content children and output the maximum number. This looks like it should be a matching algorithm. I also get a slight hint of DP here, but it doesn't seem like it's so. It feels like we could definitely use a heap here. But we have some greedy children. We have some sweets, and it looks like we can at most satiate one child. I think we try to jump to the optimization, but let's get it right first, and then we'll make it fast. we sorted them both to be n log n. So what we could just do is we'll still return satisfied. What if we just iterate over all of the greedy children and then try and find the first cookie that satiates them? If it satiates them, then we'll just go forward to the next child, and if it doesn't satiate them, we'll go forward to the next child anyway. I think then we'd have a runtime of g times s. If we're going to look through the whole thing anyway, it doesn't even make sense. Actually, it might make sense to sort it. That way we give the children the highest cookie first. Otherwise, you might end up with an unoptimal problem. So what if we just iterate it over... Yeah, we'll just iterate over all the children. Wait a second. Let me see what I just deleted. I think you still get it with one true and one false. Or maybe not. Wait. What is going on? I wrote this algorithm yesterday and I was just like, wait. I sorted the list. I sorted the list so I could match the largest cookies with the child with the highest to satiate the children with the highest greed. But then I iterated over the elements in reverse, which completely undid that work. So I'm not sure why I did that. I wonder if you could get away. I'm pretty sure you can't get away with not sorting the children. Yeah, so I would say the time complexity is log n time. Or g log g plus s log s, since we're sorting both of these arrays of characters. But it looks like... Yeah, we have to sort them, and then the loop ends when we pretty much reach the end of the greedy children. So yeah, I would say g log g plus s log s with constant space. Looks like other people came up with the same solution. What's funny is that when I was writing the solution, I thought I was delusional. So it's interesting to see that we may not, but we may be all right. So then we'll try repeated substring pattern. I also wanted to see how many problems LeetCode added. Given a string s, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. What does that mean? So if we have ABAB, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. I see. If it can be constructed taking a substring of it and appending multiple copies of the substring together. Interesting. I'm getting some inklings. I'm getting some taste of palindrome problems that we've done. I'm also getting some taste of I think there's two things we have to check. One is structural, meaning it's going to ignore the order, which basically means can something like ABC, 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 or is something like ABC, 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 do we have the properties to duplicate a substring and it still be the same? One way we can know this answer is by loading the characters into a map, and we'd get something like, for example, in example 1, we know that we have 2 occurrences of A and 2 occurrences of B. Now something has the properties duplicatable properties if we have the same number of occurrences, right? Then we could just say, right, AB, AB. But the issue with this version is that it doesn't necessarily say if we have AA and BB, right? And we have to take a specific substring like AA, BB, or AB, or BA, and duplicate it twice. So this doesn't acknowledge order. So the second thing we need to do is acknowledge order and build acknowledge the order by building the substring from the pattern and checking if it equals S. The way we build it from the pattern is if we just load it into the map, the order the keys are in the map will show us pretty much what the not exactly actually. Actually, maybe we don't need to acknowledge the order, because us just knowing the answer to 1 says that there is some order you can arrange this where that would be true. But this AABB string gives me an issue. Yes, with part 1, we'll know that the substring that we're looking for is 2 characters long. And then the question is, if we duplicate the first, so we do have to acknowledge the order. We're building the substring from the pattern, checking if it equals S. The way we'll do that, we'll know the length of the substring from step 1, and we'll pretty much just take the substring from the first step, right, AB, and duplicate it 4 times, or duplicate it X number of times, and check if it equals S. And if we do that for all of these, ABC, actually, this doesn't work. maybe there's a different way we can do this and just check the string itself. What if we did something like 2 pointers? We just started at A, and then we check. We have 1 pointer start at A and 1 pointer start at 1 index after A. Right? And we'll say, oh, okay, they're not the same. Then we'll start at A now, right? And then we'll try and go through and make sure that they are the same through and through. Now, what if the string is ABCDA, ABCDA? Now that I'm realizing it, I think I might be overcomplicating this. If the string can be repeatable up to a specific number of times, the string has to at minimum start with the first character in S, which means we can just check every occurrence where it could start. Now let's see how long our string can be. It can be up to 10 to the 4. So we could do this in linear time, I think. ABC. Actually, wait a second. I see. ABAB. Right. I see what they're saying here. Well, I think I have an idea. Maybe we can break it down into even and odd test cases. If we create a set from S, what do we get here? Oh, I'm supposed to print the set, not S. Do we get each individual letter? We do. So what we can say is if s.length mod 2 does not equal 0, which means we have an odd number of characters, right? And set.length does not equal 1. I mean set.size not equal 1, then we're going to have to return false. So I think this should work on all odd test cases, because the only time it's odd and you can keep repeating it is when the character is the same. Now when it's even, there's only so many delineations where you can repeat it. So if we have a length of 4, the size has to be 2. Now if we have something like this, we have 12 characters. The max this can be is either 12 well, let's check. What does the answer look like if we have something like A could be A 4 times. What if you have something like A B C D? What I'm trying to test is if this returns true. If this returns true, that means you can have something being repeated once. So you can have six. We have something called potential lengths, which would be an array. What we can basically do is say while s.length, we'll start at 2, and we'll say while length is greater than 0. We'll say if s.length mod len equals 0, then we have potential lengths dot push len. Then we'll do len minus equal 2. Now if I print this, I don't understand. S.length minus 2 should give you 2, while length is greater than 0. If length mod len for mod 2 equals 0, which it does. Oh, God. I'm trying to print potential lengths. Yikes. And then for all the potential, this is going to be a crazy runtime. I is less than s.length plus, and we'll have substring, which will be equal to s dot substring start does not equal s sub I, we shall return false. Or actually what we'll do is just break. This is not the solution. You know, I think it could work. We're just going to wrap around, and instead of doing I here, we do I mod substring dot length and if they don't match, we'll break out. This feels ghetto. I don't think this is how they want us to solve it. Plus, if the string is dumb long, our runtime becomes literal trash. I do think this above portion here with the odd stuff does work though. There's gotta be a better way to tell what the ideal substring index is. Maybe we could do a removal thing. What if we just reverse the first half of the string? 1, 2, 3, 4, 5, 6. Then we have 6 characters here. If we reversed it from the mid half, then you could just run a string reversal algorithm on it. So what if we did that? This is my last try. Reverse from mid half, check forwards, and backwards is same. So if we want to reverse it from the mid half, left equal to s dot length over 2, 1, 2, 3, 4, 5, 6, or index 0, 1, 2, 3, 4, 5. Actually, yeah, the length over 2 actually works perfect. And then we can go over right. This is going to be s dot length minus 1. Left is less than right. Let temp equals s sub left. And then since we saved s sub left, we're going to overwrite with s sub. First we have to spread the string into an array. And then we'll do r sub right equals r sub temp. Do left plus equal 1, right minus equal 1. Then we can duplicate this, except we'll set left equal to 0, and right equal to length minus 1. We can replace this nonsense here. And we'll say if r sub left is not equal r sub right, return false. And then at the end, we'll return true. At s is equal to a, for some reason this returns, I return true here. So if set mod 2 is not equal 0, which means it's odd, and set dot size equals 1, and s dot length equals 1, then we should return false. But if set dot size s mod 2 1 does not equal 0. Set dot size does not equal, well, it does equal 1, so why are we returning false? we're returning true, so we're making it all the way to the end. I think we need one more case, basically. If s dot length equals 1, we should return false. Now that I'm thinking about it, I think you could do this in n squared time if you just brute force the checking. But we'll save that for next time, and I think we should be able to solve this tomorrow.